Hello everyone, this is just a continuation of the part one that we talked about the Spring Boot observability, wherein we discussed about the bird eye view of how the observability comes into picture and how the different tooling works and how they link together, helping us with debugging and like figuring out things beforehand. If you haven't watched the previous video, I would highly recommend watching it so that you get an idea of how things are connecting with each other. In this video, we will just dive into taking a Spring Boot application with an open source tool and then instrumenting the application. If you are using a paid tool and the configuration might differ, you might be using their own agent. In case of Dynatrace, you might be using one agent, and then in case of Elastic, say for example, you might be using Fleet agent. So this is just to get started with it, and then to understand how basically logs, traces, and metrics work and how they link together and correlate with each other. Now let's dive into the actual coding sample to get more clarity on it. So this is what we are going to do as part of this video. Here we have a Spring Boot application. It's a multi-module POM project wherein we have the client and the server. At some point in time we will communicate with between this client and server, but like to begin with we will start with the client, just the client. And the Spring Boot application will be connecting to different backends for communicating and then transmitting the data points. The first thing that it would communicate is with the Loki. So the Loki is the data backend for logs, wherein those logs are stored. And with respect to trace, we have Zipkin here, wherein we would either use one of these dependencies in our Spring Boot application to connect to the Zipkin. Earlier versions of the Zipkin doesn't support OTel, but right now the version that's currently I'm on is 3.4 Spring Boot version that supports the OTel. So we will be transmitting the traces into the Zipkin, whereas in case of Prometheus for the metrics, like we have the Prometheus backend here, and then we will be using the micrometer registry, which is going to register the metrics endpoint for Prometheus, which is /actuator/ Prometheus, right? So metrics / Prometheus, which will then like convert the metrics from the metrics endpoint to that of the version that Prometheus could understand. This is where a little bit of difference comes in, if at all, if we use a OTel in the middle. But like for this demonstration, we will just stick with Prometheus directly talking to the application. And from the visualization side, we got a Grafana here, and then we will use the Grafana data source to import Loki, Zipkin, and Prometheus into the Grafana so that we could view all of them in the Grafana workspace. To do that, we will be just using the data source connection, or alternatively you can also use YAML config connection. For this, we are going to use the Docker compose file from GitHub, wherein I have posted this Docker compose file, which will have Grafana, Zipkin, Prometheus. So we will just run these three, and then along with the Grafana instance, just to have it up and running. Once you start this thing, it's going to start it up, and then for which you might need you might need the Prometheus YAML as well. So but like we will get into it like in detail later on as part of this video. Now we will just navigate to the Grafana application, and then we go to the data source and click on add new data source. When you start with, you might not see these data sources, you might need to add them from the beginning. So you can just click on here, and then you can provide the valid endpoint, which is Loki 3100. So why we are saying localhost instead of Loki is because I have specified this as part of the internal Grafana network, so it would be referring it with the host name here. With the even though I haven't specified it with the host name here, it's just going to work that way. Okay, so being said that, we'll go back and add Prometheus and Zipkin as such, right? So by going into the new data source, we will add the Prometheus and the Grafana. So we will see something like this. So in this case, I will just go and delete it since I have already added them. Here we got the delete option, and then I can delete it for now. Okay, so that's the configuration that you might need to do from the Grafana side. To start with, we will just start with the logging to Loki. But before going to that, I have already made the Spring Boot application, which is a multi-module Spring Boot application with the client and server. To begin with, we will just start with client and then move on. If you check the dependency of this project, you will see the Actuator, Spring Boot Web, since we are using Tomcat. We also got a Swagger UI endpoint in here, and then just the Lombok. And then we'll just go check the client application. If you see the client application, it's just nothing but a Spring Boot application, the run endpoint, and then we have the rest of it commented out. And then if I go to the log back, we have this log back appender. So if at all, if we do not have this appender log back at all, then what Spring will use its default pattern, but in this case we are overriding with our own pattern. Here we got the timeline, and then we are highlighting the level, which will print the log level in blue, and then the thread information in green, and the actual file name in cyan, and then the actual message itself. So in the application properties, we got the port set to 8088 and the application name set to client app. So it's just nothing but a normal out of the box Spring Boot application with a controller get endpoint, and then we will just start the Spring Boot client application here. Looks like the application has started. Let's go to our Swagger. So to navigate to Swagger, I will have to do Swagger HTML. So we have this endpoint. I will make a call here. So try it out, execute, and then it returns hello world. Voila. Now it should print the first instrumentation logging message without any. So as we saw here, so this is the timestamp that we have specified in the log back, the log level, and the thread information, the thread that's actually running the request, right? So and then this is the file name, and this is going to be the actual message that's getting printed, right? So that's exactly it. Now this is not going to ship the logs to Loki right now, isn't it? So we might need to tell the dependency in the first place, which we are going to do it right now. So we will just add this appender dependency. Once we kind of add this in, what would end up happening is we will have the access to the appender here. We'll go ahead and enable this first. So whatever we have logged in here is the same thing that we are trying to log here. So it's app service name and the host name, and this level here, log level, the message, the thread name, the logger level, and log level here. And then here the app corresponds, I believe, to the property here, which is Spring Boot instrumentation, and the service name corresponds to this property client application. And the host name will be pulled from my machine's host name, and this is the actual log level. And if you look at it here, this is where our Loki is running. So this is the endpoint for pushing the logs to Loki. So this is the default one. So since we have enabled this, and then we will go ahead and restart the application. Before that, we can also go and see if it had written any logs to Loki in the first place, right? Let's go here. See, we haven't had any logs for an hour. So let me go ahead and restart. Now I have the application running, so let it give a minute. Okay, now we got the logs here. Okay, Spring Boot, run query, and then if you see, there is a spike here which says info, and then if you drill down here, this is the message that we are trying to do, and the reason why you see a blank space here is that's because we have commented these two things, which we will dive later in this video. So if I click on this, it's going to show the fields. This probably could be a baggage for you. In this case, we see the app as Spring Boot, and then the level as info, the host name level as info, again service name as in client app. That's coming from the configuration that we had as part of the label. Now that we have seen the successful shipping of log message to Loki, we will just jump into the next part of this video, which is tracing, for which we would go ahead and start the server application. If you look at it, it's just again a typical Spring Boot application wherein it has other endpoints, but we will slowly dig into it. But for now, what we are trying to do is we'll be trying to make an API call from this endpoint to the other. So if you note here, we have got the REST client. If at all, if we use this, which is REST client builder base URL. So this is not going to work. The reason for it is because to the tracing to work, the Spring Boot observability suggests that we might need to have it as part of the REST client.builder. Say in case if you are using REST template, it would be REST template.builder, or if at all if you are using web client, it would be web client.builder. So that's how a trace gets enabled to to have it like auto instrumented, or else you might have to manually pass it as part of the trace parent, which is not recommended, right? So we will just stick to that. Now we have got these ones, then we will have to go back to our logs, right? So we'll have to go back to our logs and then enable these two lines which we had commented out. So what this does is like it's going to copy the trace ID from the MDC. MDC is nothing but the thread local of the particular request, and this is also going to copy the span ID from the MDC into here. So this is going to write it in this two fields respectively. So this will also copy the trace from the MDC and then populate it here, right? Now I have the similar configuration on the server side as well, but like for the simplicity I will just stick with here, and then we will move on to the server later on. And to have this enabled, we will also need this in place, which will say like where to ship the spans for the tracing, and also you will have the probability sampling probability. So this varies between 1 and 0, wherein like if you want, say in case of like high throughput application, you might not want to sample every single request that's coming to your application. So that's so you might put a percentage of like how many requests that you might need to sample, right? So that's the advantage of that particular property. Okay, given being said that like this is good with respect to transferring the information to the loki. Now going back to the application properties, this is good. Now we will actually have to go and enable the dependencies. Okay, let's do that by going into the actual POM here, down here. To do that, what we are currently going to do is we are just going to disable this instead of Brave. There are different reasons for it, because it's better to stick with OTel. It has a better better standard. That's what we discussed earlier in the previous video. And then here we are trying to export it to Zipkin. That's why we have this exporter to Zipkin, but like it will be shipping it in the Opal telemetry format instead of like shipping it in the Brave, because last time I tried the baggage wasn't working with the Brave, which we will talk about it in a little bit. But for now, like just let's consider like we will transmit this in the form of OTel, right? So that's what it is. So this is going to transmit the data as if like from the micrometer version to the OTel version, and that's going to ship the OTel telemetry data to the Zipkin backend. Okay, being said that, let's start the server application at this point in time. Not sure if server will start. Let's see. Well, the server has started, and this should also ship the logs, because we have the same configuration down here as well. So they should ship the logs together. Now let's go and see the client. So we have enabled this. Let's restart the client. Not sure if I did it. This has been restarted. Now if I click on it, I see the basic endpoint as well right now. So if I try that out and then execute, it's returned me the hello world. And if I go to my log, so in the client application, I see the trace for this particular request. And then if I copy this over and then go and search for it, I find this in the server. Now it's a point wherein we need to check, see if this is working as is in the Grafana. Let's go here, go to explore, Loki down here, app, Spring Boot, run query, and then we see the log down here. Okay, so we have the trace, and then we have copied the trace, right? So we can alternatively go here and then add the trace and run query. So that's just going to show me the ones that are connected, right? So that's going to give me the trace. So on the split screen, what I will do is right? So I will flip this to Zipkin here and then copy the trace and then run. So that's going to give me the trace. So if you see here, like this is giving me the trace of the client application is called, and then it has called the server application, and it took this much of time to process the actual request, right? So this is done. Now what if I were to tell you that, say when I click on this, it also shows the trace ID here, and then if you see this link bar here, which when I click on it, it will automatically take me here. So how do I configure this? So to do that, what I will need to do is I will have to go back to data source, Loki, and then if I see here, so I have the derived fields down here. So wherein I will have to type in the trace ID here, and then it's going to reject the trace ID from here, and then it's going to copy it over to the query. So which I'm just going to link it to the Zipkin. That way, what it happens to happen is, whenever say I'm looking at a trace, I have the Zipkin's link in here, so I can navigate between these two guys right now. So that makes things handy. At the same time, you can do it the other way around by going in here. It should show us in log. By clicking here, it should take you here, right? So to do that, you would have to go into the data source of Zipkin, and then if you scroll down here, trace to logs. So here I'm just using the trace ID. Alternatively, you can use span ID so that it actually takes you to that particular log message for that span. Now we got to know about the trace and how it belongs, right? So it's the trace again is across the board, meaning like across multiple different services, wherein the span differs based on, like, how we configure it. It's typically across a single service, but we could even split the span as how we see it needed. Now being said that, in the real world scenario, we will not get this from the user saying that, hey, this is my trace ID, but in some cases we might eject, in case of error we might throw the trace ID back to the user so they can come back to us. But in a real world scenario, like, there could be a product ID that might be missing, there could be a student ID that is causing an issue, or there could be a user ID, so that could be causing an issue. So in which case we will be given with the user ID to trace what actually has happened. So how would we do that? So that's where the custom baggages comes into the picture, wherein along with the trace and the span, similar to the trace and span, we can pass in our custom baggage information into the context, so that's getting propagated. So to get into it, like, what we will do is, on the client application side, we will uncomment this part, right? Wherein if you look at it here, so we are getting the user ID. If not, then we are passing it to a default user. In the real world scenario, you might be getting that from the authentication token, right? So authentication, so wherein you can wire it here and then you can get the user information. But in this case, like, I'm just getting the user information from the user, like, when I hit the endpoint, and then I will pass it to the service as in like X user ID endpoint. Ideally, what will happen is, you can also send this as part of the actual thread local itself, but for this context I will just use this X user ID. On the server application, if you see, this is the endpoint that's going to handle it. And if you notice that we have added this annotation called AddBaggage. So what this is going to do is, like, this is going to read the X user ID header. So to go into it, like, this is the custom annotation that we wrote, and then we got the AOP. So to have the AOP working, so we might need to uncomment the AOP here. We are going to inject the span and then add the baggage here. So we will collect the user ID from the user ID header, and then we will just add the baggage as part of the tracer. This tracer is coming from the micrometer itself. If you look closely, we haven't enabled this bean because we have commented it out, and this piece of code is not used at all. So we have the span and the user ID injected within this span scope that's sitting within this annotation. The reason for it is because there is a scope for each span, and and the baggage will live within that particular span. So this span is responsible for, or like would add the baggage around this particular method. So that's the reason we are using aspect, wherein if we use interceptor, it would have added the baggage at the level of interceptor, but when it lands on the controller endpoint, we may not be able to guarantee that if it is of part of the same span or it could be a different span altogether. So for those reasons, we are adding it as part of the aspect. Alternatively, we can proxy it and then add it as well. That's other way of doing it. But for this demonstration, I will just stick with AOP. On the server logback, we have logged the user ID as part of the actual label, which is like the baggage, and as well as part of the console log, so that when we run the application, we should be able to see that happening. On the server side, we have like multiple of these methods. So each one of them are like for different type of spans. So if you look into here, so we have called hello world new span, and then async new span and the continue new span. So these two are going to be async and these two are going to be on the main thread. So this is going to create a new span and this is technically going to be a continue span. If I go into here, I have annotated this with new span, and in case of the normal one, it's by default is going to be continuous span, meaning this is going to be the same span of that of the hello world, wherein in this case this log will happen in a different span, wherein this the log within it will happen in a different span. And with respect to the async, so the new span is going to happen in its own new span, and the continuous span is going to happen in a continuous span. So if you haven't annotated with the continuous span, then you will not be able to transmit the span of the parent, unlike if you are running it on main thread. Now let's restart both the application client and the application server, since we have made a bit of change. Assuming both has started, I'm just going back to the browser. I'll just reload it so that I get the new trace get method. Here in the user, I'll just try Surya, then execute. Now if I were to check the logs on the server, I should start seeing Surya getting printed. Now we have printed the user ID in here. Now say Tom, and then again Surya, right? So I have made multiple number of queries right now, so it should have created all those references in here. Now if I want to track my particular request that I made, I can go to Loki again, click on application Spring Boot here, and then just search for Surya. That's going to give me the context that came with my ID. And if you see here, like the user ID, that's logged, but alternatively we can also check the label and then select it, filter it based on the user ID. So if not we want to do it that way. So now we can click on this, and that's going to show the trace again here. Also note that you see the my async here, so that's coming from the async configuration bean that has the thread prefix name, and also you see the tracing configuration here, and this is what is kind of propagating the trace context right now. Now we know how we could add a custom injection into the baggage and then see how we could track it across the board, like say user ID. Now let's move on to a next thing wherein we could see how many such events occurred. Say to observe that, we will just uncomment this endpoint, and if we take a look at it, similar to user ID, we have got the tenant ID in here. So right now we are also passing in the tenant ID from the client application, and then we will see like how many times the tenant is getting invoked. This is similar to like checking see how many users have placed an order in their cart but haven't proceeded to the payment. Like similarly, like we will check, see how many users have made a query on a certain tenants, right? So as part of the metrics. So this is on the client side, and the server side is where the metrics is going to happen. So to do that, like first thing first, we would just uncomment these two properties. At the same time, we'll have to go into the into the dependency section, wherein we would need to enable the Prometheus, right, for this to work. So we'll enable the Prometheus, so which is what our metrics backend is. And then if we actually go to the coding part, it's straightforward and easy. We will just have this observed annotation, wherein we will give this key which will be referred, and we will give a contextual name. This is nothing but having a specific name for this particular server. So here if you see, it's showing get slash trace, and that's not ugly at all, but this gives this contextual name to that method technically. And if you see here, we have these two methods, so service method here and the control service method. We'll just first take a look at this one, so wherein we just have another observe basic method annotated with observed, which will print the actual method itself. But if you look at the second method, what we have in here is, like, we are setting the cardinality key value, the high cardinality key value and the low cardinality key value. So say, when would you set a high cardinality key value and when would you set a low cardinality key value? Is, say, there might be millions of users out there using your application, so that goes into the high cardinality key value, and there will be only certain tenants, so making it easy for you to figure it out as part of the low cardinality key value. Behind the scenes, what it aids for it is to apply the filter on the data backend side and to make it efficient. What happens if you put the user ID in here? Certain metrics backends deal with them. If a threshold exceeds, then they will push that to high cardinality value, and then you might end up losing the user metric information, or like you might end up having an incorrect information. So that's about it. So now, just before restarting, so this is something that I wanted to touch up earlier in this video. So this Prometheus YAML is something that we would need to have it as part of the Docker. So before we start the Prometheus, like the actual Docker compose itself, like we need to have this config. So this will have, like, what are all the endpoints that it need to scrape. So and then it will have the actual endpoints that it's trying to read the data from. Now let's go and restart both of those applications. So they have started. I'm going to go into Swagger, reload it. Now I should start seeing the observe. Okay, here we go. It's here, down here. Let me try it out and then say user, and let me call the tenant maybe AWS. Or well, so now we see the Nicole one here, down here, and then we see the user ID. We click on the Zipkin endpoint. Now if you see here, all those methods that we annotated with observe is giving more started giving more sense down here, right? So and this took this much time. And if you look here, there is a link option that I made, which is going to give a count by tenant. If I click here, it's going to take me to Prometheus, and it's going to show me like the tenant Azure. So it's gonna show me 4 of them pointed it out to it, and that's why we see the count to be 4. And if I want to just search without it, I can just remove it, and I believe that's going to give you both the AWS and the Azure that we made. So we made 2 AWS and we made 4 Azure. So this way we can count, or like we can do other type of metrics. If you are wondering where this metric is coming from, then that's going to be from the metrics endpoint. So let's go to server, which is running on 8081 is actuator metrics. And then if you look at it, you would have these observed endpoints as part of here, right? And then we have it as part of non-active, right now. So we will do this. This is where it is coming from, right? So it has a total count of 6, 4 plus 2, and then it has the tags to be AWS and Azure. To further classify and check see how many Azure or how many AWS here, we can also do /tag and AWS. That's going to give us, we got 2 from the AWS, which is what is technically showing up there. But is this what the information is going there? If you ask, this is the actual information that's getting there, but it's not getting there in this format as in like a JSON, but rather it's getting transmitted in Prometheus format like this. That's why we have it registered like this. If it was supposed to be in the OTL format, and it would be in a different OTL format. So this particular scenario, we are just sending that in the format that Prometheus can read. Since we are importing the data source into the Grafana, it gives us a nice view of the data. But let's say if you have your server running right now, so I have turned that off. Well, now if I try go to this Swagger endpoint, and if I try to hit SI and then hit here, so this client should throw me an exception, isn't it? Right now I can go here and then in the Loki, if I see by error, it's going to show me that, right? It's going to show me that error, and then it's going to show me the trace. Then if I click on it, it's going to take me to the Zipkin, and it says, hey, my get failed. That way we know like what actually failed. Clicking on here, and then if I click on observe, and then if I look on this span attributes, it's going to show me the Azure and Kathy as well in here. I can click on logs for the span, but right now I haven't enabled it based on the span, but rather I have it tracked to the trace ID, so it's going to take me based on the trace ID, right? So it's going to take me back on the trace ID. So that's pretty much it. So this way, we could juggle back and forth around these things and then try to investigate a little better, right? So that's the total crux of this. I hope this has given you an understanding of how to debug and how to configure things so that you could make your lives a little bit easier as developers or as like a support engineer. So all these code bases that we discussed in this, I will be providing a GitHub link in the description box below, and I will be also attaching a Medium link just in case if you want a readable version of it. Thanks for watching. See you in the next one.